Good morning to one and all. I am Dr. Tirupataiah Kasani, Assistant Professor in the Department of Mechanical Engineering at School of Engineering and Technology, Adamas University, Kolkata, India. Today, I welcome you all for the last class in the module Unconventional Machining Process. And we have already seen the most important unconventional machining processes in the first three classes. Namely, in the first class, the abrasive jet machining and ultrasonic machining. In the second class, electron discharge machining or electric discharge machining, EDM. And in the third class, the electrochemical machining, ECM process. Now, in this class, we are going to deal with a few more unconventional machining process which are important. Okay. Now, the contents of each unconventional manufacturing process discussion will follows like this. Contents: introduction, working principle, material removal mechanism, applications, advantages and disadvantages. Electron beam machining. Here, the name of the unconventional, that is unconventional machining process, is electron beam machining process, EBM, the shortcut form. See here, electron beam machining process. If you see this electron beam machining process, the energy that is used for removing the material from the workpiece is electron beam energy. That is high moving velocity electron kinetic energy is converted into heat energy, and that results in melting of the material and vaporization. Okay, we'll see. First, we will go through this schematic of EBM setup. This is arrangement of electron beam machining setup. This is how the setup is looking like. First, we will start with the electron gun. What is this electron gun? Electron gun is the element which ejects or which emits the high velocity electrons when it is subjected to a high potential difference or high voltage. Okay, generally this is the tungsten filament will be there inside this. This is the tungsten filament. Okay, which is responsible or from which the high speed electrons are ejected out when the high voltage will be supplied to this. And this is the grid. See here, this is the DC power supply. This is the diaphragm. This is the plus and negative. This is the electron gun, that is. This is the negative and this is the positive. This is the power supply. When power supply is given, the electron gun will emit the electrons. Okay, and those electrons are negatively charged particles, and those will be attracted or accelerated by this anode. Anode means positive. Okay, this diaphragm is also a positive, means whatever the emerged electrons from the electrons are attracted by this anode, that is positively charged ion, means the velocity of the electrons are slightly increased. And this diaphragm will helps in controlling the high speed electrons. Okay, and these will be guided using this diaphragm, and these high speed electrons will pass through this diaphragm like this. And here it is the focusing lens or electromagnetic lens. Focusing lens or electromagnetic lens, which focuses all the electrons in the all the electrons, means the electron beam will be focusing, okay, using this lens at some particular point, that is over the top surface of the workpiece. This is the workpiece table. Okay, the table movement XY directions. Okay, here also as usual, this is the workpiece, means the electron beam is focused using focusing coils over the top surface of the workpiece. That is the reason why these are the focusing lens or electromagnetic lens. See here, these are the deflector coils. See here, these are the deflector coils which can guide the location or which can control the location of this electron beam. Okay, for example, I would like to concentrate this beam at this position. Let me activate this pointer. Yeah, I would like to concentrate this beam here. Then this deflection coil will help us to move this focusing point of the electron beam to here. Means this is the deflection coil which can controls the location where the electron beam is falling over the top surface of the workpiece. Okay, this is how all this will be operated, or all these elements are incorporated in a vacuum chamber. Why? What is the need of this vacuum chamber? Does it require the vacuum chamber? If it is operated in the open atmosphere, what happens? Do you know the X-rays, how harmful to the human body, and the uh, what is the, if the electrons will be emerging out, how harmful to the human body? Okay, those are very dangerous. That is the reason why in medical field also the doctors will generally suggest to take the x-rays once in a year, not more than that. Otherwise it will affects our body organs. Okay, different organs. That is the reason why the primary reason for keeping all this equipment in a vacuum chamber is that whenever these electrons, highly energy or highly charged high speed electrons, okay, when these are moving from the electron gun to the workpiece, if air molecules will be present in between, these electrons will collide with those air molecules, and those will be deviated here and there, not concentrating at one point to melt the metal. Okay, to melt and remove the material. That is the reason why, to avoid the collision of air molecules collisions with the electrons those are produced from this gun, all the setup will be kept in a vacuum chamber. Okay, that is not at the zero absolute vacuum, but it is less than, much less than the atmospheric pressure. Okay, so that it avoids the collision of the air molecules with the electrons. That is the primary reason. And now second one is, it is very harmful if the electrons are exposed to the outside atmosphere. These are the two main reasons. See here, yeah, electrons with high velocity. uh, See here, electrons are produced when high power supply, DC power supply is given. Due to high voltage, the electrons are released from the from the tungsten filament, and those are accelerated by anode to the higher speed. And as the as these electrons are going in this way, the velocity is further increased. Means the kinetic energy of the electrons from here to here is continuously increasing. All of a sudden, over the top surface of the workpiece, the kinetic energy is converted into heat energy. Means whatever the kinetic energy of the electrons is converted into heat energy, and the generated heat is melting the workpiece, and then followed by the vaporization. Okay, melting and vaporization is the material of removal mechanism in this. Okay, removal of material. And see here, this is the electron gun and this is the workpiece, and the distance will be precisely calculated and maintained at the time of construction of the equipment, so that the high speed velocities can attain its maximum. And to improve the efficiency of the process, that high velocity for the electrons is required. Okay, and now see how the material will be removed from the top surface of the workpiece. Schematic of material removal in EBM. See here, this is auxiliary workpiece. See here, this is the workpiece. What is this auxiliary workpiece? Auxiliary workpiece is the one which can support this workpiece and workpiece from the table. Here it is the actual working table, and this is the workpiece. If I will keep this workpiece directly over the table, then the table may damage due to this electron beam penetration. Means the table may gets melted in this stage. Okay, when a through hole is made, some amount of electron beam energy is penetrated into the table also. That is the reason why, to protect the table, we are keeping another workpiece called auxiliary workpiece in between the workpiece and the table to protect the table. Okay, see here, this is concentrated at single point. This is localized heating by focused electron beam. This is the position. This is how it is. As the time goes on, gradual formation of a hole. See here how thin the hole. Okay, and it is further progressed. Penetration till the auxiliary support. Yeah, it is started. If there is no auxiliary workpiece here, then if it is a table, then the table starts melting. Okay, that is the reason why, to avoid that, this is the auxiliary workpiece that we are using it. If the workpiece and the table will be placed, workpiece and the table will be placed, and means these two are protected with the help of this auxiliary workpiece in between. Okay, removal due to high vapor pressure. Removal due to high vapor pressure. The material will gets removed out due to this vapor pressure. Means, see here, localized heating, starting penetration, reached the bottom position, and vaporization pressure means removal due to high vapor pressure. This is the removal of the material. Electron beam machining. See here, EBM is a high energy beam machining process. This is well known. Means you can imagine the energy and the speed of the electrons very high. Okay, electrical energy is used to generate high energy electrons from the tungsten in electrode gun, from the tungsten film in electrode gun. And here it is the working principle. Electron beam machining, EBM, is a process where high velocity electrons are concentrated into a narrow beam, that is directed directed towards the workpiece, creating heat and vaporizing the material. EBM can be used for very precise cutting or boring of a wide variety of materials. Boring means enlarging or creating the through hole. Okay, boring and counter boring. That is well-known operations. You all are aware about it. And see here, this is the essential. What are the essential for performing this EBM process is vacuum chamber. We have already discussed what is the reason for providing this vacuum chamber: to avoid the air molecule collisions with the electrons which are passing or which are traveling from the all the way from electron gun to the top surface of the workpiece. The tool and workpiece are not in an atmosphere, in an open atmosphere while machining. That is required. And now a tungsten filament is used to produce the electrons, right? Mechanism of material removal is melting and rapid vaporization. We have already seen in the last figure, in the previous figure, the last stage, vaporization, removal. Material removal rate, the typical material removal rate is 0.001 centimeter cube per second. This is very fine removal. Means this electron beam machining, the material removal rate is very less. Means this we can call it as micro machining also. Means the depending upon the amount of material, we can classify the machining process: macro machining and micro machining. It is slightly towards the micro machining side, I can say. Okay, as high velocity, high voltage is applied across the cathode filament, that is tungsten filament, thermoionic emission of electrons takes place. Thermoionic means thermal energy, ionic emission. Due to the filament gets heated up, thermal energy, and then ionic emission, ions gets released. That is negatively charged ions called electrons. These electrons are attracted by the anode through the bias grid. These are electrode by anode grid. Electrons are accelerated to half of the velocity of the velocity of the light. See, velocity of the light, 3 into 10 to the power of 8 meters. Okay, half of that, the high velocity electrons are produced. EBM applications. Electron beam machining is particularly suitable for producing very small diameter of holes down to 0.002 inches. See how small the hole diameter. Micromachining in thin materials, cutting of slots and drilling of holes with very high depth to diameter ratios, usually more than 100:1. Means 100 mm depth and 1 mm diameter. You can just imagine the hole, how it is looking like. Okay, how small. Machining of wire drawing dies having small cross-sectional area. See here, the machining of wire drawing dies having small cross-sectional area. Because electrons have shorter wavelengths than the light and can be easily focused. See here, because electrons have shorter wavelengths than light and can be easily focused. Electron beam methods are particularly useful for high resolution lithography and for the manufacturing of complex integrated circuits. These are the other applications, okay, of the EBM. Welding can also be done with an electron beam, notably in the manufacture of aircraft engine parts. See here, after melting, whenever the electron beam impinges the top surface of the workpiece, the material gets melted. Okay, if immediately after the melting, if I can move the beam away from the zone, and if zone, then the liquid metal will get solidified and the joint will form. That is nothing but welding, electron beam welding. But here in this case, machining the material, the whatever the molten metal that is melted, that should be removed. Okay, that is the machining. That is the material removal. There it is melting and joining. That is welding, and this is machining. See here, advantages and disadvantages of the EBM process. Extremely close tolerances can be maintained. Yes, that is precise control of the electron beam is possible. Heat affected zones are minimum. As we have already seen, a very thin hole is formed due to the localized heating. Means high depth to less diameter is possible. That is the reason why heat affected zone is minimum. It can be machined almost any material irrespective of its mechanical properties. Okay, it can be melted. The beam can be concentrated on a very small area. It produces a better surface finish and narrow curve. The narrow curve means whatever the diameter of the slot that is produced or the hole that is produced, that is nothing but the curve. Thermal distortion is less. Why? Because thermal distortion, here the heat affected zone is less. Okay, due to the thermal energy, the heat affected zone is minimum. Thermal distortion due to the thermal energy also less. And the process is fast because it is entirely non-mechanical. Okay, and here next one is the disadvantages. Initial equipment cost is very high. The interaction of the electron beam with the workpiece surface produces a hazardous X-rays. That is obvious. Hence, shielding is necessary. That is the reason why we are keeping all this in a vacuum chamber. And further, the shielding is required to limit or to control the any leakage of X-rays to the ambient atmosphere. See, vacuum is essentially required. Skilled labor is required to accelerate the electrons. Very high voltage is required to accelerate the electrons. Okay, that's it. And next one is laser beam machining. Till now we have seen, and in this class, this is the second, and there is one more unconventional machining process. We'll try to discuss this laser beam machining. Till now we discussed electron beam machining, means highly energized electrons are used for removing the material. But here, in case of laser beam machining, laser beam energy is used for removing the material from the workpiece. We'll see laser beam machining. See here, this is the schematic of laser beam machining setup. Okay, schematic. See here, this is the power supply, high power supply, and see this is the flash lamp. Flash lamp. These two are the flash lamps on both sides. And here it is the 100% reflecting medium and partially reflecting mirror. 100% reflecting, and this is the partial reflecting. See here, this is 100%. Why? Because this is the laser discharge tube, means this is the lasing medium from where the laser is generated. Okay, whenever the power supply is on, due to this flash lamp on both sides of this lasing medium with 100% reflecting mirror and partial reflecting mirror, this lasing medium gets activated, and due to continuous collisions of those of the light, okay, a monochromatic laser medium is developed, and it is emerging out from the partially reflected mirror and not from the 100% reflecting mirror. Okay, that is the reason why partially reflecting mirror is used for taking out the laser beam from the lasing medium. Okay, now the power supply is given, flash lamp is active, flash lamp is on, and laser medium gets activated and produced the laser beam, and that beam is transferred out, and that will be concentrated using the lens. Okay, single wavelength in phase light. Okay, laser, that is nothing but the laser. This is the, what is the length between the focusing lens and the top side of the workpiece, we can call this as focal length. Okay, this helps in controlling the position where the laser beam is supposed to be fall over the top surface of the workpiece. See here, this is the focused light and this is the workpiece. Here the principle is the same as that of the electron beam, means the laser beam, when it hits the top surface of the workpiece, it gets melted, okay, and evaporated. Means evaporated, melting and evaporation, means this is the machining process, so material removal has to be taken place. That is the reason why melting and vaporization. Okay, see here how the material removal mechanism in case of laser beam machining. See here, this is the laser beam and this is the conduction mode of heat, means this is the workpiece initially, means the beam is falling here, and due to conduction most of the amount is transferred to the bulk portion of the workpiece. Okay, after that the melting is started to some portion, and then the melting of the metal is stopped, but this whatever the already melted molten metal is pushed further, such that, but here the conduction mode of heat transfer is continuous in these three cases. Okay, here this is the amount of material that is melted. Here the further melting of the metal is stopped, and here see here the laser beam, it is further, means the region, this is the region, it will be increased now. Okay, from here to here little bit increase, from here to here further increase. Okay, after that this is the final stage, this is laser beam is exposing a fresh material again from E, again the same phenomena A B C D, means conduction, melting will be expanded. Okay, melting is extended, further melting. Okay, and the molten metal is removed from that region through some means. Okay, like vaporization, that is fine, melting and vaporization. Laser beam machining used light energy from a laser to remove material by vaporization and ablation. By vaporization and ablation. Okay, energy is concentrated optically. Yeah, we are using the lens to concentrate the laser beam. Laser emits either continuous or pulsed light beam. Okay, laser may be pulsed or continuous. That is the reason why if it is a pulsed one, then there should be an intermittent gap between the supply of this laser beam to the machining zone. If it is a continuous, then that is a continuous, means this intermittent will be preferred for the machining process and the continuous will be preferred for the welding process. Okay, as I told, melting, vaporization is a material removal. Elements of the lasing medium, means I told that between the two flash lamps there is a lasing medium that will be gas, liquid or solid, maybe any one of these. Okay, and the next pumping process is nothing but the continuous reflections, and the next one is optical feedback element. Okay, if something will be if something will be happened with respect to the optical elements in the equipment or in the system, then there should be a feedback system, okay, to tell to the controller that there is a damage to some particular element. That is the reason why optical feedback element is necessary. See here, this is the ND-AG solid state laser. This is the optical resonator, means resonator between these two. This is highly reflective mirror and partially reflective mirror. These are the two mirrors. In between these two, due to this flash lamp, that is the pump source, and the crystal, that is laser medium. This, due to the continuous collisions, this laser will be coming out. Okay, from this is the laser medium or lasing medium. This is the Nd:YAG solid type laser. See here, types of lasers: gaseous laser, solid laser, excimer laser. Okay, and the working principle is when a high temperature laser beam strikes the workpiece, yes, the metal starts melting due to high temperature and high speed. Okay, due to high temperature and high speed. Metal starts melting due to conversion of the kinetic energy into thermal energy. Mechanism of material removal is cutting, vaporization, and chemical degradation. See here, this is melting and vaporization, actually, not cutting. This is melting, vaporization, and chemical degradation. The material removal rate is 0.1 mm cube per minute. See here, 0.1 mm. See here, let me edit this here only. Melting, vaporization, and chemical degradation. Material removal rate is 0.1 mm cube per minute. Okay. And see here, laser beam machining. These are the applications. Heavy manufacturing. Okay. Seam and smart welding. Spot welding. Spot welding is a kind of welding wherein there is no continuous joint between the plates. This is at, at few locations to set the position of the plates before the continuous welding. This spot welding will be used. Yeah. Light manufacturing, that is engraving and drilling purpose, and in electronics field, skiving of circuits and wire stripping, and medical field, cosmetic surgery and hair removal. And the advantages will be selective material removal. Okay, fine amount of material from intricate portions is possible using this LBM, and flexibility and fully automated. And the disadvantages, when it comes to the disadvantages, requires specially trained operators. Okay, not for mass metal removal process. As you know, this is not for mass metal, means high amount of material removal process, not meant for that. Okay, requires greater control of joint tolerances. Otherwise, see here, requires greater control of the joint tolerance, means precise control of the laser beam is very much important to improve the strength. That is the reason why requires skilled operators. Okay, and this is the expensive equipment and consume much energy. And the final one is final unconventional machining process is the plasma arc machining process. Plasma arc machining process. In all these, there is no direct contact of the workpiece with the tool at all. Okay, similarly, in this also PAM, there is no direct contact of the workpiece with the tool. See here, schematic of plasma arc machining setup. See here, plasma, highly energized gas. Okay, highly energized gas is nothing but the plasma. This is the arc machining process. See here, plasma arc machining is consisting of, this is the workpiece from which I would like to remove the material, and this is the tool, tungsten electrode, that is cathode, workpiece is the anode positive, and this is the negative. Here it is the power supply to this and to this. Now there is a nozzle, double nozzle here. See here, through through the annular space between the nozzles, a gas is supplied. Okay, inside nozzle is supplied with water cooled. Okay, water circulation, that is water cooled nozzle. This blue color indicates the water cooled. Why? Because this is the tungsten electrode. Okay, in the TIG machining or in the TIG process also we are using the same tungsten electrode. Okay, high temperature withstanding capability. Okay, and this is the water cooled nozzle, and in the annular space of the nozzle the gas is supplied, and this is the outer nozzle, that is copper nozzle, that is the anode. And here, due to the high potential difference between the workpiece and this tungsten electrode, the plasma is generated, followed by the arc generation. Arc we can see with the naked eye, we can observe it, but it is very high intensive in nature. We can't see the arc with our naked eyes directly. Okay, that is the reason why using the protective shield we can observe the arc between these two. Okay, similar to that in case of EDM. Okay, between the workpiece and the electrode. Okay, the plasma medium will be developed. Okay, followed by the spark generation. Here also in the open atmosphere, the plasma is generated, followed by the arc generation. See here, the gas flow is directing towards the arc region only. This gas, what is this gas and why it is? Okay, we will see that down the line with the help of one more figure. See here, this is the electrode, means tungsten. I can wrap up the wire to this like this. Okay, this is the negative and workpiece is the positive. Whenever I am supplying the power, then there is a potential difference existing between the workpiece and the electrode. Electrode means tungsten electrode. See here, whatever the cutting gases, see here outer nozzle, this is the outer nozzle, this is the inner nozzle. See here water shield. In this annular, in this nozzle annular space we are circulating the water, but here in the annular nozzle annular space we are supplying this gas. Okay, depending upon the requirement. See here, cutting gases. What is this cutting gases? Means whatever the gases that are responsible for the formation of this plasma followed by the arc, those are nothing but the cutting gases. Here also, whatever the gases that is coming here and coming here through this space, which forms the plasma here, followed by the arc. Okay, and now we will see this is the arc generation. Due to the arc formation, high amount of energy is concentrated over the top surface of the workpiece, and that will be melted, and that will be taken out with the help of the gas flow. This gas flow, okay, this gas will come like this, and it will go like this. See here, here the blue color, the water will be used to take out the machined or the melted molten metal out. Okay, this is the flow of the water. Means after melting, okay, generally this plasma arc machining will be used for cutting. Means that is removing the material. Means plasma arc cutting is a very common equipment in all the central workshops in the educational institutes, most of the educational institutes. That is the reason why here this is the gas which is taking out the molten metal from the machining region. See here, water is responsible for taking out the molten material from the machining region. Okay, that is the means we can select the medium, either water, fluid, or some other gas we can supply through it. Okay, depending upon the application and the material that you want to machine. Plasma arc machining employs a high velocity jet of high temperature gas to melt and displace material in its path. See here, plasma arc machining employs a high velocity jet of high temperature gas to melt and displace material in its path. Working principle: the torch produces a high velocity jet of high temperature ionized gas, that is plasma, that cuts the melting and displacing material from the workpiece. Okay, plasma, that is superheated and electrically ionized gases at approximately 5000 degrees centigrade. See here, the temperature of the plasma ions is directed on the workpiece in the form of high velocity stream. Mechanism of material removal, melting and vaporization. As we know already, melting and taking out with the help of melting. Sometimes depending upon the situation, depending upon the material, depending upon the environment, we can select melting and vaporization or melting and removal of the molten metal. Okay, whatever it may be. Plasma arc machining applications, welding of cryogenic, aerospace and high temperature corrosion resistant alloys, nuclear submarine pipe system and welding steel rocket motor case. Okay, that is very much important application. Welding of stainless steel tubes. See here, welding, that is joining, means after melting the metal, we are not taking that molten metal from the machining region. Okay, just we are using this plasma arc for melting the metal at the machining region. After that, that will be allowed to solidify there only to make the joint with the rocket motor case, that is welding. Okay, welding steel rocket motor, welding of stainless steel tubes. Similarly, welding titanium plates up to 8 mm thickness. Plasma arc machining is used in the machining of jet engine blades, in the machining of jet engine blades. And finally, the plasma arc machining advantages. It gives a faster production rate. A very hard and brittle metals can be machined, and small cavities can be machined with good dimensional accuracy. Here, this is the good dimensional accuracy. And when it comes to the disadvantages, initial cost is very high. Okay, it is uneconomical for bigger cavities to be machined. Okay, inert gas consumption is high. Why? Because we are going, sometimes we are going to supply inside and outside space of the inner nozzle, means the annular space of the nozzle and the center core portion of the, means which is surrounding the tungsten electrode. In both these regions we are about to supply some inert gas only. That is the reason why consumption is very high. Means now we will see various types of plasma arc cutting. See here, the cutting and machining. Okay, both are same, means the removal of the material only. But when it comes to the joining, that is welding, we are allowing the molten metal there only to solidify, so that the joint will be formed between the two components. See here, various types of plasma arc cutting. See here, conventional plasma arc cutting. Arc is constructed by a nozzle only. No shielding gas is added. Cutting gas is tangentially injected into the electrode. The swirl action of the gas causes the cooler portions of the gas to move radially outward, forming a protective boundary layer on the inside of the nozzle bore. See here, conventional plasma arc cutting, what it is. Let me activate this laser pointer. Conventional plasma arc cutting. Arc is constructed by a nozzle only, means there is no need of a separate electrode. Okay, no shielding gas is added. That is the conventional plasma arc. Cutting gas, that is inside core gas, is tangentially injected into the electrode intentionally. The swirl action of the gas causes the cooled portion of the gas to move radially outward, forming a protective boundary layer of the inside of the nozzle bore. Means that is nothing but, see here, if you observe here, this is the cutting gas, that is swirl motion. This is the swirl motion here. Okay, are you able to observe this? This is the swirl motion. This is inside bore. This is the inside nozzle. This is the swirl action. Okay, now the swirl action of the gas causes the cooler portions of the gas, causes the cooler portion of gas to remove radially outward, forming a protective boundary layer on the inside of the nozzle bore. Okay, inside nozzle. This helps prevent damage to the nozzle and extends its life. Okay, the nozzle life will be extended. Air plasma arc cutting. What is this? Air plasma arc cutting. Introduced for cutting mild steels. This air plasma arc cutting is introduced mainly for cutting the mild steels in regular workshops. Means whatever the plasma arc cutting machine that is common in all the educational institutions is a kind of this air plasma arc cutting only. Okay, oxygen in the air provides additional energy from the exothermic reaction with the molten steel, boosting cutting speeds by about 25%. See here, boosting the cutting speeds about 25%. Means cutting speeds are high. Why? Because the oxygen in the air provides additional energy. Okay, from the exothermic reaction with the molten steel. That is the reason why, due to the presence of the direct air, in that air, whatever the oxygen is responsible for providing the additional energy. This process can also be used to cut stainless steel and aluminum. Okay, stainless steel and the aluminum also. The cut surface will be heavily oxidized and thus can be unacceptable for some applications. Well, because see here, the direct air is taken in this machining process. That is the reason why the cut surface, nitrogen, oxygen, carbon dioxide, there are multiple number of gases will be present in the open atmospheric air. The cut surface will be heavily oxidized immediately after the cutting due to higher temperatures. That is the reason why, for mechanical characterization of the metals at the cut regions, those metals are mounted, polished, okay, to remove the oxides and debris and to observe the grains and grain structures. Okay, that is one kind of reason for polishing. Dual flow plasma arc cutting. See here, dual flow plasma arc is a slight modification of, see here, dual flow plasma arc cutting is a slight modification of conventional plasma arc cutting. See here, conventional plasma arc cutting, slight modification. What is that modification? See here, if you observe, this is the dual flow plasma arc cutting. This is the workpiece. Okay, outer nozzle, inside nozzle, and this is the electrode. These are the fine. Okay, this is the shielding gas from the external instead of water. This is the shielding nozzle. I can say outside nozzle is the shielding nozzle, and the nozzle annular space is filled up with the shielding gas. Okay, see here, this is the orifice gas or the cutting gas. Okay, this is the inner portion, electrode. This is the constricted nozzle. This is inside nozzle, I can say. This is the workpiece. This is the double flow plasma arc cutting. See here. Now, dual flow plasma arc cutting is a slight modification of the conventional arc cutting. Here, arc is constructed between a nozzle only, no shielding gas. But here, it is a shielding gas. Okay, outside it is shielding gas, orifice gas or the cutting gas. Here it is, arc is constructed by a nozzle only, means only nozzle and the workpiece, the arc is constructed. But here, this is the electrode and this is the workpiece. Between these two, the arc is constructed. Okay, and here the cutting gas or the orifice gas is used, and in the outer annular space, the shielding gas is used. These are the differences. The cutting gas is usually nitrogen. See here, why? Because this is the orifice gas or the cutting gas is the nitrogen. The shielding gas is selected according to the means generally the number helium, argon, neon, like that. The shielding gas is selected according to the metal to be cut. For example, if it is a aluminum, then you must and should go to the argon only, most of the cases. Cutting speeds are slightly better than those of conventional plasma arc cutting on mild steel. Cutting speeds are slightly better than those of conventional plasma arc cutting on mild steel. See here, on mild steel. But the cut quality is not acceptable for some applications. See here, cutting speeds are slightly better, but during this high speed cutting, the deburrs, the burrings are more. Means the cut is also not uniform. I can say at some portions, a high amount of metal may be removed, not in the straight line. It may be curved. Means we can't say. That is the reason why. But the cut quality is not acceptable for some application. That is the disadvantage. Cutting speed and quality on stainless steel and aluminum are essentially the same as with the conventional plasma arc. Those are conventional on the mild steel. See here. Then final type means various types of plasma arc cutting. The underwater plasma arc cutting. See here. The name itself is indicating underwater means the plasma arc cutting within the water medium. Means like in case of electron discharge machining, the machining process or the spark generation is within the dielectric medium. In case of electrolytic medium ECM process, the chemical reaction is occurring between the tool and the workpiece within the electrolyte medium, the chemical reaction. Similarly, here also under the water, okay, the plasma arc cutting is going to be happen. Underwater plasma arc cutting is suited for numerically shape cutting and produce a noise level of 85 decibels or less under normal operating conditions. Okay, means this is the noise level, the units decibels. In comparison, conventional plasma arc cutting typically produces noise levels in the range of 105 to 115. Means during the operation of this plasma arc cutting, you can hear the sounds. Okay, you can hear the sounds. That is common. Underwater cutting also nearly eliminates ultraviolet radiation and fumes. This is very much important. Underwater cutting also nearly eliminates ultraviolet radiation, UV radiation, and fumes. Why? Because all that will be under the water. It is immersed in the water medium. The steel plate being cut is supported on a cutting table with the top surface of the plate 2 to 3 inches under water. See here how this is looking like. The steel plate being cut is supported on a cutting table with the top surface of the plate 2 to 3 inches under the water. See here, this is the starting position and this is the final position. Means a beautiful color. You can observe it here. This is plasma cutting, means throughout. Means the metal will be cut, means the through cut is making to the plate in this direction. From here to it goes like this. If when it is completely underwater, this is the beautiful orange color it is looking like. Okay, 2 to 3 inches under water, that is the minimum, which results in controlling the or eliminating the UV radiation and the fumes. That is advantage with this plasma arc cutting. And this type of cutting is very much helpful in repairing the shipbuilding equipments. Okay, submarine outer structure elements. Okay, sometimes it is not possible to go to the seashore and dismantle the component and repairing it and assemble it again. It is not possible. Okay, in real world applications, means on-site repair purpose, this underwater plasma arc cutting is most an important unconventional machining process. Nowadays also most of the people are using this type of machining process only, especially in shipbuilding and submarine repair purpose. Okay, and in addition to this, that's it for the day. And with this, there is a small topic, but that is an assignment, I can say. You can study on your own. That is ion beam machining. IBM means where the positive ions are used for removing the material from the top surface of the workpiece. Means till now we are using different forms of energies to remove the material. Mm, Quickly we will recall it and we'll wind up the session or the class. The first one is the abrasive jet machining, where the highly energized or the high velocity abrasive particles mixing with the gas are impinging the top surface of the workpiece. That is erosion. The material removal mechanism is erosion. Okay, the second one is ultrasonic machining, where the abrasive particles are hidden by the tool, and those particles in turn hits the top surface of the workpiece, and which is responsible for the removal of the material from the top surface of the workpiece. The material removal mechanism is brittle fracture. Okay, and the third one is the electric discharge machining, where between the tool and the workpiece a spark is generated. Means the high amount of energy, heat energy, that is spark results in high amount of heat energy, the melting, evaporation followed by the cavitation due to the formation of the bubble, the cavitation. And the next one, electrochemical machining, that is due to the chemical action of the electrolyte. Okay, the material from the workpiece is removed. Before the material gets deposited on the other electrode, that is tool, the electrolyte flow is removing the material from the machining zone. And the next one is the electron beam machining, wherein the high velocity electrons energy is used to melt and vaporize the material from the machining zone. And the next one is the laser beam machining, where the melting and evaporation. Okay, and finally this is the plasma arc machining, where cutting and where melting and removing the molten metal from the cutting zone through some means, generally either by the flow of the gas or by the flow of the water. And and last but not the least, ion beam machining, wherein that is assignment, that is a very small topic only. Ion beam machining, wherein the positive ions energy is used to remove the material. In case of electron beam machining, negative ions charge will be used for removing the material. That is high amount of high velocity kinetic energy, means high velocity electrons are impinging the top surface of the workpiece. In case of ion beam machining, the whatever the positive ions, those will be impacting or impinging the top surface of the workpiece. That is mechanical removal of the material. There it involves mechanical energy. In case of electron beam machining, high velocity electrons impinging the top surface, creating the thermal energy, melting, evaporation. But in case of ion beam machining, it is positive ions, those will be impinging the top surface. That is mechanical energy is responsible for removing the material from the workpiece. Okay, and thank you for giving me this opportunity, and all the best for your future. Thank you.